start the recording of the session. And I also want to start by appreciating you all for joining this session today. We've been having this training session where we have different engineers coming in and discussing different topics in network engineering. We have already done 4 sessions. This is our 5th session. And today we have Peter Kinyua, who will be taking us through home labbing. Again, there is a lot of theory works, but just reading the theory works, reading those many books without any hands-on labbing on these networking topics, you may not really understand how these protocols or how these technologies work. We are always encouraged to get our hands dirty by doing the labs, by doing the simulations, because that's where you get to learn the nitty-gritties of these networking technologies and the networking protocols. That's why we are having this session to guide us on how we can set up our labs at home. It could be physical, it could be virtual. We will be hearing from Peter Kinyua. So allow me to bring in Peter Kinyua so that we can start our session today. Some rules: you expected to mute your mic. If you have a question, you can send it on the chat, or you can raise your hand if you have an issue that you need to raise, so that we avoid the disruptions during the class. So just keep your mics muted. If you have a question, raise up your hand, or you can share it on the chat, and then we will respond to them. We will have a Q&A session at the end of the session. Peter, you can take it over and do your presentation to us.
Okay, let me just turn on my camera for a bit. Good morning, everyone. I'm excited to take you through my home labbing. As you can see behind me, it's a bit hot in here, but yeah. Okay, so let's get started. I'll try not to delve much into PPT, just kind of show you how I've set up my setup looks like, and I'll do some demos here and there. Hopefully, sometimes demos usually don't work, but I've kind of been testing, like doing this for over a year, so hoping it'll work. Okay, so if it's okay with you, I'll turn off my camera and then start sharing my PPT, and then we can just go through the agenda.
Yes, Peter.
All right. Okay. Screen. Okay. There we go. If you can see my PPT, then we are good to go. Okay. Why even do a home lab? The reason why, many people have different reasons, but for me, I wanted to kind of delve much deeper into networking, and kind of also whatever sits on top of the network, the application part. So there was no way to accomplish that without paying a lot of money on AWS or Azure to do this. So I just decided to invest and kind of just go out, and it's been a journey. So I'm going to take you through the journey I took to get here. So I'll talk about these key topics today, like how I started, progressed, the networking aspect of it. I might have to do another session at some point to kind of now dive deeper into like the network emulation tools you guys are talking about, the GNS3, the EVE-NG, the Peanut Lab. I have Peanut Lab learning in the lab, as I'll show. But yeah, hypervisors, virtualization, automation, observability, and how all this can assist your career. Uh, it also can be a good hobby. I mean, if you have a lot of time on your hands, if you like learning and you like learning practically, a home lab is the best way. You never run out of material to experiment on. There are so many open source projects that are out there. People just put them out there. You can test them, improve them, customize them. You can also take this as a way for you to a foundation. If you have a business and you don't want to go with cloud resources, you want to do a home setup, you want to do an on-prem setup, understanding all this will help you kind of just run your business on open source tools so that you Amazon or Azure, they're not getting a cut of your profit every month. So again, self-hosting, just hosting application on your own and kind of without renting servers. So you're doing it locally to the highest extent. When it comes to getting out of the internet, of course, you have to rely on the ISP, DNS, you have to rely on the top DNS like Cloudflare and all that kind of stuff. But everything else, you can do it yourself. So my journey started with a gaming laptop. My wife had an old laptop. I took it, and when we upgraded to another computer and kind of was interested, started with that. I installed an application called Casa OS. Kind of now introduced me to Docker containers, all that kind of stuff. And the journey took off from there. So again, my setup evolved from a gaming laptop to mini PCs, the Raspberry Pi, and then at some point I added a Threadripper, and then at some point, again, it's an addictive hobby. So you kind of you find yourself investing more and more into it, but I don't mind it. So this is how I started. I started with that old gaming PC up there. I kind of enjoyed working with containers, understanding that I was running PNet Lab in it, a hypervisor, Proxmox, and the resources were not enough. So I decided to go and get mini PCs and get a switch to do VLANs to connect the hypervisors, and I did that. And then I got a Raspberry Pi, and then I got a power distribution unit to connect all of them together, and the home lab came together like that. And then this is the second phase of evolution. I added a big switch that can do 10 gig, but now my network cannot do 10 gig. So what do I do? Again, go do an upgrade. And this is where now the upgrade started to move to a bigger rack with more hardware. And this is where I landed. So again, I added this hardware step by step. Most of it is home lab, but most of it is also running my home network. So my Wi-Fi runs on it, my IoT. So it's production in essence, and also home labbing a lab in the other essence. So I try to make it as such a way that it's painless to use the network. So I kind of separate the network, as I'll show you later on. And you can see my planning was not very good. I ended up having to put stuff in behind my rack, and you can see my cabling, my cable management, all that kind of stuff. So essentially what I have here is, this is a workstation. It has a GPU in it, which comes in handy when you're trying to do anything with AI or trying to do anything that requires GPU as acceleration. I have a NAS, which is the production NAS, where I store everything I don't want to touch, and then everything else I have a NAS that I can experiment with, and then the switch, and then a small cluster for clustering and all that kind of stuff, and then another switch that can do 10 gig and cluster all these small PCs together. Some stuff to talk about. Usually when you're getting hardware, you need to also kind of factor in, okay, do you want to be able to do more storage, expand your networking? There is PCIe bifurcation. You can get PCIe lane and then split it into 4 if your motherboard and your CPU supports it, and you can have more PCIe devices. So like this is a PCIe bifurcation card for NVMe. So I can have 4 NVMEs and I can put them in there, and then I can split the PCIe lane into 4 lanes. I can address each SSD as if it's connected directly to the CPU. And this is a 10 gig NIC. It's right here, 10 gig NIC. Again, expandability is something you have to keep in mind. Cooling is also another thing. Like this workstation gets a bit hot without the right kind of cooling, so I had to I bought it used, so I had to go in there, get new fans, and kind of upgrade it, and now it's working just fine. And that's my mini cluster for experimentation. You can see I have 3 devices. They're all interconnected with 10 gig. They are connected to the switch. Using 2.5 gig for management. I also have the 2 10 gig SFP ports, and it's also interconnected with Thunderbolt, which comes in handy for networking at high speed, up to 20 gigs on each Thunderbolt port. This is kind of just now all the hardware I recovered when I was upgrading. I just brought it on my desk and kind of now I used it as a setup to experiment. So you can see the Raspberry Pi in a tiny computer, and the switch and some screens in there to just kind of experiment with. Yeah, again, like I said, heat and noise is something you have to consider if you're going to get something used, a laptop, a server, or a switch. Power consumption is also another thing. Size, if you want to go to a rack, something like that, expansion and all that. So networking is a foundation for everything. So like I said, so you can have kind of a stack here. So you see your network sits at the bottom of it, and if everything above fails, everyone blames the network. So the network is kind of the basis of your home lab, and then the compute will be now your servers, your hypervisors will be on top of your compute, and then now the virtualization to run the containers, the applications, and all that kind of stuff, and then the application themselves. So you can design your home lab to do VLANs, or you can go the route data center go. So my setup, I have a mixture of both, where I have VLANs for every purpose, and I have this in an experimental cluster. And you can see the VLAN setup looks like this. You have your hypervisors. They have connection to the switches, and then you have your hypervisor bridges connecting to switches, and they are in trunk ports with the VLANs passing through. Again, I'll show this in my lab. And this is how my setup looks like. So my setup, I have a DNS controller hosted, I have a DHCP, and then the controller that manages the network. So too much theory, I'll just go right in and just show you how I have this setup. I'll just stop the slides for a bit. And so my network, like I said, is all UniFi. And again, I'll show this. I don't have any public IP exposed, so I can comfortably show this. So these are all my devices, and it's quite a big network. I have access points, I have switches and all that kind of stuff. I have the NAS, I have the cameras, and all that. And if you can go in networking, I can show you like the design. You can see I have multiple VLANs. So I have a VLAN for managing the network devices, a VLAN for applications, a VLAN for Proxmox servers management, trusted VLAN, IoT VLAN, and so many VLANs. So again, this is the fast kind of way to segment your network. So the IoT network cannot talk to any other network because I don't trust any IoT device I buy. And And then you need the management network for the switches. No other device can connect to it. Again, there are firewall rules and those kind of stuff that you can set up in your network depending on what kind of hardware you're using to do that. Again, this is the basis of everything. If the network is not working right, everything else you put on top of it will not work. So it's kind of a big decision point when you're going out to get hardware and when you're deciding on what to use for setup. You can also use virtualized network setup, like you can use pfSense, OpenSense. You can also use an open source project for Wi-Fi. I think there is also another open source project for Wi-Fi that you can utilize. You can install an OpenWRT. It's an open source project for Wi-Fi. You can install that on a hardware that you own, and it can do routing, and it can also provide you with Wi-Fi if you have a Wi-Fi adapter and a Wi-Fi setup to connect to it. So some policies. So I have policies for, like, if I have a VPN connected, if I need to connect to a VPN client, VPN back home. And yeah, so this is entire network. So I can go to the topology and kind of show you, like, I have so many devices. I can just filter by the network devices. I don't know whether this is visible. You can see at the top, it's kind of a campus network, a top-down. At the top, that's my ISP, and then the gateway, and then you go to, from the gateway now, you subdivide to wireless devices. This is a wireless access point, and then this is my 10 gig switch. And then the 10 gig switch connects to the other switches. I was trying not to daisy chain as many switches as possible, so just have one core switch, and then if you can have two core switches, it would be much better. You put them together and have them set up in HA, but this is a home lab, gonna spend a lot of money on that. So you just do that and then ensure that your STP setup, you can see my STP root, and then the other ones will be below it. But again, I don't have any problem because I can have any loop here unless I have an interconnection between the switches that are on the same kind of level. And you can see this is everything on that VLAN for management, and you can see the switches are in that VLAN. Some of my nodes are also connecting to that VLAN, but they cannot use that VLAN. My hypervisors sit on this VLAN here, and you can see them right there. So I have quite a lot of them, like they're all sitting there, and you can see the hypervisor, like this one, this hypervisor here is connected to the aggregation switch by through a 10 gig connection. This is the small cluster with the multiple, like you can go to that, you can see these are the small clusters with multiple SFP ports on it, and you can see the devices connected to it. So this is the fast kind of, this is the fast kind of method you can do to network your network. You just use VLAN. So subdivide everything, and then you have your router doing your inter-VLAN routing. So if I need, we go back to my networks. So if I need anything, like if I have an application sitting in this and I needed to talk to an IoT device, so it has to go all the way to the router and then come back, all that kind of stuff. So kind of a router on a stick networking philosophy. Firewall rules, they're also kind of important. The other thing is, if you're doing Wi-Fi, you kind of also have to factor in what kind of Wi-Fi 2.4, 6 gigahertz. Usually for my setup, I decided to just go with Wi-Fi 7, go with 6 gigahertz, because there is a lot of noise in the air, and there's quite a lot of people broadcasting the 2.4 gigahertz. If I go to the 2.4 gigahertz, you can see like the airwaves are very crowded, and you can see, these are all my neighbors. They're all quite crowded, and you can see my access point sits in this frequency range, and everyone else is also crowded in there. So my Wi-Fi experience on 2.4 will not be very good. But if I go to 5 gigahertz, you can see now the field becomes less crowded. And now if I go to 6 gigahertz, there's no one literally. It's just me in the neighborhood. So yeah, so that's something to consider when you also sorry.
Yes, there is a question from Shebu.
Yeah, sure.
Good afternoon, everyone. I hope I'm audible.
Yeah, we can
And
hear.
yeah, apologies to interrupt you there, Peter. Just sitting in a very hot seat. I just have a question to pose there. While you're still there, I'm seeing you running some sort of a unified controller, if I'm not mistaken.
Yep.
Yeah. How would one go about configuring for switch port security using an NPS server?
Using a what kind of server?
NPS server. NPS already a server integrated with Windows Active Directory.
So the application itself has you can do the configuration on the application. I think there is having integrated radius to my setup, because I'm just using the controller itself, the unified host as the radius server.
Yeah.
But
Okay.
there is an integration somewhere in the system where you can use. Let me see. Those are kind of some of the stuff I haven't gotten to set up.
Yeah, I know you can set a profile for a radius server, which is an network policy services server integrated with Active Directory. I've only tried that with the Wi-Fi, radius Wi-Fi, but I have not tried it with the protocol 802.3. So
yeah.
I just want if it's the same process or there's a difference there.
I think it is the same process. I haven't done any of that integration. Again, because this is a home lab setup, I just set it to default. I haven't kind of changed any of that.
All right. While you're still there, can you just go to? I'm sorry, man. I'm just watching from a smaller screen. I'm using someone's laptop here to join in. Yeah, while you're still there on your Unified controller, can you go to settings?
Okay. Yeah, that's the settings page for the controller.
Where do you configure for your profiles? I think we using different firmware versions.
Yeah. I'm up to the latest firmware.
I know from the one that I'm using, there's an option for settings. I mean, for profiles under settings where you can configure for a switch port profile and a radius server, something like that.
Yeah. Again, most of that is detailed in the Unified docs. I haven't set up that because, again, I don't have like 100 people coming to my house and I need to use radius for them to authenticate. I don't have multiple admins. I'm just the only one. So it's something you can, of course, I can experiment with by having set that up.
Yeah, because I have something coming up as part of one of our customers' compliance, and then they require for a radius authentication to be configured on the switch ports. So just try to kind of like figure out on a way to achieve that.
the good thing with with UniFi, you can host this controller in a VM, and if you have a UniFi device, you can try that.
Yeah.
Yeah, like you can get the UniFi from the website, and you can host it on your Windows computer, and then you can adopt a device into it and kind of test all those kind of setup. It is one.
Sorry to interrupt. Are there any virtual devices that one can run on either GNS3 or EVNG?
They don't have virtual appliances for those, but if you have an hypervisor or if you have a VMware workstation, you can run the controller from one VMware workstation.
Can you rephrase on that?
Or they have a controller you can install on any VM. So if you have a VMware workstation, you can boot up a Ubuntu VM and install the controller. You
so
can
in
also
the sense of switches and switches. There's no way one can get maybe templates.
No, you can. You can. You have to have a switch to adopt to it and then test with it.
Physical hardware.
Yeah, you have to have the physical hardware, but you don't need the physical hardware for the controller, the brains of it.
I understand what you're saying, but now one would need some sort of UniFi or Ubiquiti virtual appliance to test that.
Yeah, they again, like I say, the controller is open. I mean, it's not open source, but you can self-host the controller. Like in my case,
I'm aware of that.
Mm-hmm.
I'm aware of that. I was just asking in a sense of virtual switches, maybe that one can
they don't have that
on either.
Okay, they don't have virtual. They don't have virtual switches. It's not like they don't have those images out in. They don't have the way that you can go get an iOS XE, iOS XR. You can get that for Ubiquiti.
Okay. All right. No.
Yeah.
Thank you, Peter.
All right. So again, like I said, this is so this is the common setup, like separating everything to VLANs, and if your VLAN setup, like let's say this is one of my Proxmox node. If I go to that node, you can see this one. See, I'm using VLAN 11, and this is a node. It's on that VLAN, and everything else on that VLAN can talk to each other. Proxmox. You can see all my 14 interfaces, but several devices on the same. Okay. If I could redesign my network, there is also, like, this is just a mock-up of my network design. My controller sits somewhere, the access point sits somewhere. An edge switch, and then this is just my lab setup, and this is kind of the server rack and all that. Has all the equipment on it. Cabling, this one here, I'm using Ethernet over power line communication to get from one side of the house to the other. Some I have to run cables through the house to get from the controller to the main switch, which is kind of a headache. Again, this is not a requirement for HomeLab, but some vendors, they provide these kind of tools for free. Like if you want to design for 2.4 gigahertz, you can see your coverage depending on where your access points are placed. For 5 gigahertz, you can also check out if you have access point placed different places, and you can see 6 gigahertz. It tends to be, the coverage is not very wide, but you can see it's not interfere with much of whatever is around my neighborhood. They also have a protect system. Again, this is not an infomercial for UniFi. I'm just showing, like, if you want to do it professionally, this is how you do it. If you're doing it from a small business or for a home setup, this kind of gear. Again, Unify is not the only option. I'm just showing what I have implemented. And you can go to the website, like the Unify Design Center. They have, you can design your port utilization, how you want to connect your devices. And then you can export your BOM and kind of see what kind of a budget you want to use. Or again, this is no requirement for a home network, and you can do your topology again on the same website. This is how my topology looks like, and this is how I just kind of set it up in design. Like I have my servers, my switches, and access points set up.
Yes, Peter.
So that, yep.
Seems Evans has a burning question. He has been raising up his hand all along. Evans, if you can quickly ask your question so that we give Peter time to complete the presentation.
Hey, Peter. Hello?
Yes, Peter. Yes, Mugo. We can hear you.
No, from the explanation. Peter.
Yes.
This is a physical setup you have.
Yeah, this is a physical setup, physical hardware. Again, like I said, Ubiquiti doesn't support emulation. The only emulation you can do is for their controller. You can set up their controller in your own equipment, and then you have to use their own hardware.
Okay.
Yeah. So all this is physical. Like all this inventory here is physical inventory.
Okay.
Yeah.
No, that is good. Now, when it comes now, if you me, I want to build. I'm trying to use GNS or EVNG to build a lab. GNS3 EVNG. I don't have a physical equipment.
So again, for the labbing part now, I'll explain that. If you let me continue with the slides and all that. I'm just trying to paint a picture. There is a story I'm telling, and then at the end of it, you can gather all the questions, kind of visit and see how you can also get involved, how you can set up if you don't have physical hardware. How do you do the home labbing?
Yes. I'm interested in that. Yes.
Yeah. So I have like prepared a presentation. We can preserve the questions to the far end of the session so that we don't keep on going back and forth and interrupting the flow.
That's okay.
We're also time constrained, so we can reserve the question to the far end of the session.
Yeah, that is okay.
Yeah. I'm gonna do some demos and kind of explain the philosophies of it, and then again, this is the first session. We can also do a follow-up later on, if that's okay with everyone.
That is okay.
Yes, Peter.
Yeah.
Let's continue.
Yeah. So, like I said, so my setup, again, you can see I have VLAN setup. My setup is using VLANs. Sorry, I have to jump to the slides I was on. Okay. So this is pattern A. So you can have VLANs, and then you have VLAN specific for every network. And then you can do your inter-VLAN routing, and then you can have your firewall rules and policies depending on how you implement them. Again, there is open source software you can use. You can use pfSense. pfSense has a community edition. OpenSense is open source, and it can do a software implementation. You just need a computer that has a NIC, or you can get a USB. You can get a USB to. You can get a USB adapter that has a NIC, has a RJ45 connection, and you can have two NICs on the computer, and you can implement that and have a router right there to do the VLANs, the firewall rules, and all that kind of stuff. So the other pattern is what most data centers and the hyperscalers implement. So that goes to the realm of using fabrics, using EVPN. So you have your underlay, and then you have your overlay, and then your hypervisors or anything else sits on top of it. Again, I've implemented this in the home lab, and I'll again show you that. But before I do that, I need to also cover how do I do DNS. Again, my DHCP is being done directly from the router, but how do I do DNS? So how do I implement my DNS records? So I'll go to my so my home lab. I have a home lab dashboard. Again, this is all hosted in Docker. You can do this in Kubernetes. Again, I'll show you all that, but I'm just trying to kind of walk you through it. So my DNS, I have two DNSs running, and I have a primary and secondary DNS. So the network is configured. If I go to every network here, application and services, you can see defining my DNS server somewhere. If you can see it, right there, DHCP range. Where is DNS? If I can find it. Where is DNS? Maybe that one is not defined. Again, if I can find it, but the network is, every time a client requests an IP, they get pointed to my DNS servers. The DNS servers, I decided to go with an external DNS server. Again, I'm using Technetium. There are other DNS, home lab DNS. You can use AdGuard, you can use Firehole. This is especially good if you want to block ads and all that kind of stuff. So I'm just gonna log in and kind of show you around. Again, the basics of DNS, setting up zones. My setup comes with option to cluster, so that I can have a backup and active and standby. And if I go to the dashboard, you can see like this is my active DNS, and see 18 clients, 5 on the standby. I don't know why. Zones, I implement my zones, and you can see in the zones I have just a main zone for my top domain. Then my other subdomains, I have records in there for like applications that I'm running that are behind that. So like if I go back to this dashboard, most of my applications, I'm using TLS certificates. They're hosted somewhere in the server, and they have an IP address. How do I get to them? Let's say like GitLab. I have a GitLab application I'm running, so I need to be able to resolve this to an IP address to where the server is running. And you can see I'm able to get to it because the DNS is able to resolve that. So let me go back. Sorry.
Hello, Peter. Sorry to disturb you. I want to know if there is some any presentation, because I cannot see. I'm just listening to you, but I cannot see any presentation. Is there any?
Let me start sharing again. Entire screen. So can you see my screen? Yeah. So okay.
No, I cannot see. Sorry.
Is everyone having the same issue?
We are able to see your screen, Peter.
No, we can
From his end.
see your screen. I think maybe he must just disconnect and reconnect again.
Yeah,
Maybe
yeah. I think
wherever
you need to.
Okay, let me do.
Yeah. So like I was saying again, I'm just displaying my DNS server. So again, I'll show you kind of how did I set this up, and I show you how it's hosted. If you give me time, so I just have it ordered in a particular order, so that I'll get to that on that particular section, like how did I set this up and how you can also do it yourself. again, zones, and you can see like these are all my applications, and you can see the records in here. If I kind of drill down to one record like this, let's say, and and again, this is, like say, if I want to resolve that host, and I can resolve, and you can see the DNS record right there. This is an application I have hosted here called Kestra. I'll show what it does, and you can see the record right there. It's answered from this DNS server, and I can also try to ask. Again, these are not publicly accessible. So if I ask another DNS like Cloudflare, they will not know who it is. They're not going to return anything. They just return my Cloudflare records. But I don't have that subdomain in Cloudflare because this is internally. Again, I can also try to resolve from this server, and then again do it from the secondary server, resolve, and you can see this is the secondary server, DNS2, and it also returns my IP address where the application lives. Again, this is one of the essential things you need to set up for DNS, because if you want to use certificates, you want to use TLS, you want to use DNS names for your application or for anything you host in the home lab, you need a DNS server, essentially. This can also do DHCP. Again, I'm not doing DHCP here. I'm just using the Unified Application Controller because it has more features. Again, there is a lot of way to do DHCP. You can also, if you have OpenSense or pfSense, you can do DHCP from OpenSense and all that. Also doing ad blocking, so you can see some kind of malicious, like this is Samsung trying to check what I'm watching on my TV. So you can see like 76 attempts, and it's all blocked. So it kind of helps a lot, and you can configure all that. You can configure all that in your DNS. Again, host of choice. AdGuard Home does it, Pi-hole does it, Technetium. Kind of went with Technetium because Technetium also has API. Technetium also has API access. You can create an API key. And then, again, you can see in my dashboard, I have the DNS records and all that information from the DNS, like top domains I'm blocking, and I'm sourcing all this from the API. So this is, if you want to venture that route, that's something to consider when you're setting up your DNS. Let me go back to the PPT. Again, sorry, I have to switch between screens. Sorry. Yes. Okay, so the other setup, if you want to now set up your network, again, this is overkill for home lab. So this is how data center do it, hyperscalers, they do it, to route between servers, to route between sites. So essentially, you want a virtual machine to be able to talk to another virtual machine and see if they are connected on the same layer 2 network across different nodes. So VXLAN comes into place, and then you have your BGP, VPN, and your VTELs and all that kind of setup. So before I just go into Proxmox and kind of show you how I've implemented this, I'll kind of just show you, usually the hypervisor I'm using, again, I'll touch on it. The hypervisor I'm using, I can define a bridge and ports. I can also define, lags, so LACP lags, and I can also do routing. So I can use FRR, which is an open source tool. Can install it in any Linux system, can run FRR, and you can use it to do your routing decisions. And then the forwarding is also, of course, done by the Linux the underlay Linux kernel. This is just doing the routing decision around that kind of stuff. This is your control plane. So I have a setup. I have, like, again, I have 3 nodes interconnected. I have them connected with Thunderbolt. And then I have Open Fabric. Open Fabric is an ISIS derivative. So this is the underlay of the cluster, and then the overlay, I'm doing IBGP between the 3 devices, and then these are the SAFI and the AFI, the address families for EVPN. I'm connecting, I'm adding to my setup. And then at the end of the day, I want VMs on a particular VNet, which is kind of like a VLAN, to be able to talk to each other. And then the layer 3 VNI will be able to route between VLANs. So this is how I have set up. I'll open my setup and kind of show you how I've done it. Again, this is an overkill for the network. Why would you want to do this? Again, for failover, live migration, storage, you want a distributed storage. You want storage in one host to be, you want to have different boxes doing storage, and they are all interconnected, and your hypervisors are kind of writing to all the distributed storage, so that when you have one node go down, your VMs migrate automatically to the other node, and they are able to do that because the storage is shared. So again, there's a container, there's a networking that it's involved for your storage layer. Ceph does that very, very well. It's overkill for the home lab, but again, you're doing a home lab to also try to experiment with something that also enterprise grade. So I'll go ahead and show you how I have done my cluster setup. So again, I'll exit out of that, and I'll go back to my handy dashboard. So these are all my Proxmox. These are all my hypervisors. I'll go to the data center manager and kind of just log into the data center manager. And so these are all my nodes. So I have an edge node, I have a cluster. This is a Fusion cluster. So I have 3 nodes in the cluster. I have some other nodes that are standalone. So this is the cluster I'm doing the experimentation for SD1 and all that kind of stuff. So you can see there, you can see the cluster has its own local network, and you also have a fabric network. I'll log into it and just show you how I've done it. Again, all this information is accessible now with AI and all kind of stuff. There's so many articles about it. I'm just showing you my own implementation of it, and I can show you like it can also be done for a home lab, and for what purpose you cannot quite actually learn a lot from it. So I'll go to one of the nodes in the cluster, and again, this is one of the nodes in the cluster. I'll log into it. Again, I need a password manager because this is not manageable. So this is my, if you can screen my screen, this is my 3-node cluster. And you can see that there is a fabric right there, networking fabric, another networking fabric, another networking fabric there. If I go to the data center, and if I go to the data center and go to networking, again, this is the cluster. If I go to the data center, clusters, SDN, yeah, there we go. So I need to apply all these to synchronize them. Again, it's a finicky setup because I'm using Thunderbolt. I'm using Thunderbolt connection. So again, I have to reload the cluster sometimes because there are so many knobs to tune which I haven't quite gotten right. Again, so like, again, you can see that the fabric is not okay. Maybe I can just go in and show you like show you kind of the setup here. I can just log into one of the nodes. You can see my terminal. So again, like I said, you can use FRR. You can install FRR on any node, and you can turn it to a router. As long as it can do routing underneath, I can do forwarding. You can install FRR. So this is, so again, you can see I have the FRR config on this node. Every other node also has the same config, and you can see my connection. I have Thunderbolt interfaces connecting to the Open Fabric, and then I have my BGP, my BGP configs. Again, all these are done automatically. You can do it on the GUI. You can also handwrite the config yourself, but for the initial setup, you need to handwrite the config to understand it and all that kind of stuff. And then you have the AVPN setup. Again, this is the Open Fabric setup. Again, you can see it uses the same kind of philosophy as ISIS. You can see the network ID, the net ID ISIS uses. If I go back to the network, let me see whether the SDN synced up. Okay. Let's see. Okay, now the fabrics are okay. You can see the fabrics are okay, and now the nodes can talk to each other. Again, the advantage of this, like in this node here, the advantage of this is, you see, I'm using Thunderbolt. Thunderbolt is quite much faster than, I'm using Thunderbolt connection, which has about 20 gigs, and you can do up to 20 gigs between nodes. Let me see. Which is also something you can also experiment with if you have a home lab. If you have any Thunderbolt interconnection, you can, if you have like in this case, I'm using small PCs. These are small PCs. I'm interconnecting them together with Thunderbolt. They have Thunderbolt ports, interconnecting them, and then doing the clustering. See whether I can pull a diagram. Again, showing you all this, a diagram will probably be better. Let me just pull a diagram. Again, I have a diagramming tool I can just show you. So this is a Fusion cluster. So diagramming tool here. And again, so the VMs, you can see the VM seat on top here. And then you have the VXLAN for L2 and L3, and then you have the control plane, and then the Open Fabric, and then you have your meshing, interconnection of nodes. Again, this is helping in terms of, if I have this link go down, you can still have connection to the cluster through this other route. This helps a lot. Data center setup, hyperscaler, they set it up. And again, this is a simplified setup, but hyperscaler essentially use this kind of technique. Again, this is just a tool I'm using for the diagrams. Again, I'll point it out what it is, but I'll show how this is done, but I'm just defining my diagram as code here, and it renders the diagram for me. I think I can also show the Thunderbolt. I can also show the speed test. Again, Thunderbolt has it's quite impressive. Again, you have some challenges you encounter with that, but so I can run a simple IPAF test on between the two nodes in the cluster, and then just make sure the packets are sourced from the Thunderbolt interconnection. So I'll do it from the okay. So if you just run an IPAF test. Just start an IPAF server here. Then on this other side, I'll connect to it with some flags set. If it's gonna work. Okay, there you go. You can see that's the benefit of that. So it's quite, you can see the 4 lanes getting up to about 18 gigabits per second between the 2 nodes. I'll be doing a write-up on this if anyone is interested to see how I've set it up and kind of make more sense. With this, I was just doing a demo to just show you, again, you can do this in your home lab, and it's something you can experiment with. My other section, I was going to explain why I went with Proxmox. Again, you can use VMware. They've made EXSI free to use again. I mean, you can use, there's a free tier again. They took away that previously. I haven't cared to experiment with it a lot. I just want to just kind of build on Proxmox. Again, I can also test on other hypervisors out there. XPNG is one that's popular. Again, it's open source. LXCs have little cluster loads. Again, like I showed, you can do Proxmox XDN, you can do APIs. I'll show this when I come to touch on automation. So I'll try to do some automation, an automation demo somewhere. So when you are doing your application, when you're setting up your application, again, you have your basics. Let me go to presentation. Well, this is not a good view. Sorry. Okay. So when you are setting up your application, again, remember that pyramid we started with. You have your network. We covered like the VLANs and all that kind of stuff. You have your compute. That's the hypervisors. That's the physical nodes, and then the hypervisor, and then on this layer up here, so you have options to set up your applications. So you can go with full VMs. Again, you still need a VM even if you choose to go this route. So you can do VMs. You get binaries, install them, and then if you need reverse proxying, you can get those, install them. This is how typically we used to set up infrastructure in the past, and then now this has been the norm for quite a while, using containers, and again, container orchestration using Kubernetes, and this is the original OG Kubernetes K8s, which originates from the Google project Borg. Again, I'll show this, how I have this implemented in the network. My setup, I have VM set up, and then on top of VMs, I install Docker, and then the application live in Docker. I also have some setups that use Kubernetes. Again, I'll show you that. VMs will be great for learning Linux, those kind of Linux, Linux skills you need for administering your server. Even if you're a network engineer, you find yourself, you're setting up applications that monitor your network, and they live on a VM somewhere. You need to understand how to do that. You need to understand how to log into a database when your topology is not syncing up, whether your records are in the database. You need to be able to query that. Again, that's kind of where this kind of skill comes in play. Again, I can jump into my setup and kind of show you now my virtualization setup. I'll probably just go into a node that has, so I'll just go back to my dashboard. I'll go to a node that has quite a lot. So this is my edge node, and I kind of overloaded it a lot. Let me just use the certificate. Yeah, there you go. The TLS encrypted route. So this is my edge node. Again, if I go back to the network and kind of just point out where it lives, you see it right here, where you edge network. Again, the topology does its own thing. Unify can't get it to work correctly, but it's connected to this guy right here on the edge of the network. It's right there. You can see that's the IP. interconnection, and if I go to that connection, you can see it lives on this VLAN 11. Again, like I said, your networking, networking will be the foundation of everything. If this is not working, I'll not be able to resolve the DNS record for it. I'll not be able to reach it. Any automation I have running, no work. If it's again, you can see this is my VM that's running most of my stuff that can call production. The DNS is running in there. I can just log into it for a second, show you what the application looks like. Again, I have so again, the application running here are Docker applications. And you can see that's my DNS server right there, Technician DNS. I have an uptime monitoring system. I have a tool for managing Docker. Again, I can jump into this tool and you'll be able to see all this, how it's set up. So I'll go to my handy dashboard and go back to home. And this is my tool right there. I'll log into it. Again, there are so many environments I'm running, so I have them interconnected. So this is the VM I was on. And again, you can go up there and you can see all my setup. So you can see so if the setup is, if the application is created on here, you can manage it from here. But I bootstrap this directly from the VM, so I can see it, and you can see that's the DNS, and these are all the backups I'm storing on the Alpine container. So that if this goes down, I can still go to the backup and I can restore it on another setup. I can get my records from the backup. I can also, this volume right here, I can get that volume and I can also back it up if I need to restore my DNS if it crashes. The uptime application, this is a simple setup. I can show you, like, this is just a simple Docker Compose file. I just define the application, the image it's using, and put it in a network. Again, there is also networking involved when you come to Docker. And without the foundation for like the traditional networking, this will also not make sense at all. I can go to this guy and I can jump to it. The uptime right there, and that's just an uptime demo for just monitoring my infrastructure. So if I want to see my, let's say, the ISP modem that connects to my router, if I want to see how it's doing, you can see the uptime, and you can see it went down at some point last night, and I can get all these records. Again, this is the infrastructure supporting the network, and this is kind of sits up there. And as network engineers, we tend to ignore this, but if you want to be all-rounded, this is kind of stuff you want to get into. I also have a monitoring system. I think most of you will probably be familiar with Zabbix. I also have Zabbix. This is my Zabbix setup. It's probably not up to date monitoring my infrastructure, but I have set up SNMP traps to come to this server, and you can see this is kind of just a mirror of my own infrastructure, my core router, my ISP gateway, the server itself, doing all the SNMP traps, and everything else. I haven't updated the topology because I added new hardware, but this is essentially what's there. Again, this will give you like an NMS setup, and again, this is also possible to set up if you're using EVE-NG PNetLab. You can deploy a server and then drop Zabbix as a Docker agent in there and monitor your topologies, monitor your routers, your Cisco routers, send the SNMP traps, monitor them here, and then you can do the observability. You can go now make graphs from them. If I go to this one, if the graphs load, there is some data in here, but it's not cleaned up. But you can see the ICMP responses being received on the bridge interface. Again, I haven't cleaned this up yet, but you can see I'm able to get the traps and also visualize that using Zabbix. Zabbix also has Zabbix also has API. You can see I have a API going to my Grafana instance, so I can pull metrics from Zabbix and put them on other dashboard to graph out my metrics, which I'll also again come to it later. Again, I think that's enough for that section. I'll go now to my automation section. So again, as you've seen, I think Martin will note the questions and then we'll tackle them at the end of the session, if that's okay with you. I know there are so many questions, but we have limited time. I just wanted to give a high-level overview, and then we can do the demos and the questions part.
Yes, just complete your presentation, then we'll have sessions coming in a few.
Okay, so we've seen this. Again, I also have so the Docker Compose route, the Kubernetes route. So you can see again, it also becomes hectic now, starting to manage all these Docker VMs, all these virtual machines, and then you have Docker running it, and then you have application in them. Like this one is just doing dashboard, and that's the dashboard I'm looking at right there. This dashboard right here. This dashboard right here is this guy right here, and you can see the definition. I have defined it, and then this is a device proxy I'm running on it, and it becomes hectic to manage that. That's where now you move to another technology called Kubernetes. 5G is moving to Kubernetes. I recently did an article. I did a write-up. We can just do a detour for just a second. I did just a lab. Again, I implemented this in Pnet Lab, which is an EvenG clone that has more features. It's like Pnet. It's like EvenG Professional. It's not being updated anymore, but you can go check it out. Again, I recently did a 5G setup, and I did like how 5G cloud native application is set up, and I set up a VM. I installed a container that has a simulator for a node, for a phone, a simulator for a GNodeB, and then the control plane. That's the control function, the AMF, those who are familiar with wireless technology. And then the UPF will be your gateway to the internet or to your data network. And I did another VM for that. And I did this simulation. I have an extensive write-up on my GitHub repo. Again, I think I can open my local GitHub Git repo. Again, I have a repo here, and I did an excellent, this is also on my GitHub. This is my local repository kind of a Git management, Git tool, but I did a write-up. You can go look it up on GitHub. Again, I'll share this if you're interested in setting it up. But I set this up using EvenG, Pnet Lab. So you can see I had VMs, and then I installed Kubernetes on top, and then ran all these containers, did all the networking. These are topologies I need to explain that, log into the 5G core, log into the 5G control plane, set up a test mobile system, and then now try to verify all that by logging to the container, the phone, try to ping, try to capture packet. There's a lot you can do with this, but don't be afraid to learn Docker. Again, there's AI to kind of simplify stuff. There are so many docs out there, so many open source projects on GitHub, and networking community to explain all this stuff. And that's the fun of it, learning new stuff and, using it in your career, using it as your hobby, using it to grow your business, whatever you want to do with the knowledge or the skills you get. Again, sorry to deviate. So I'll just show you my Kubernetes setup. I have several Kubernetes setup. I have a single node cluster. This is where now my Git is running. This is the application. I also have another application. If I filter here to another namespace, sorry, I have a repository for storing all my Docker images, like Docker Hub, but locally hosted. I have another repository. I have another tool for deploying the application called Argo CD. Yeah, so with Kubernetes, you can do a lot. You can also accomplish the same with Docker, but this is more efficient and it's more geared to cloud native kind of setup. That is how most applications are deployed in the cloud, and you can experiment with this and set up your network tools in that format. I'm sure most of you are interested. I can go and kind of show you how the Zabbix, I have my Zabbix set up. If I can find it, again, it becomes, it's on this here and here, and this is my Zabbix stack. And you can see this is the application I was monitoring my network. You see there is a web application. This is the front end I'm reaching the application on, and then this is the server. Then this is the database I'm using MySQL. Again, this is typical. Like if you work with like Huawei Gear, they have their own NMS, and it's deployed in a similar fashion. Zabbix will be open source. I mean, it's not fully open source, but it has you can use it for free. There's also an enterprise edition version where you can get enterprise support. But as a business, you can use it for your business as long as you're not violating the terms of the license they have in place. And then there's an agent. This is now the agent that's polling. You can poll your servers with this agent, collect the metrics, send them to the database, and then send them to the server, and then your front end can visualize all that. Okay. So I'll go to the other part. Again, for engineers, even when I started, I didn't do much automation, and automation is very crucial. I'll just paint a picture for you. Let's say you have like 1,000 routers, and you need to manage them, or you need to change something simple like create a local user for login locally on 1,000 routers. You don't want to be doing that manually on every router. That will take you forever. Let's say you're doing, let me give you an example, fiber to the home. Fiber to the home, you can have 10 million customers, right? How do you go ahead and provision 10 million ONTs? Let's say you're moving, you're doing fiber to the home, and you're moving your customers from using public IPs to CGNAT, and you want to change all these ONTs, a million ONTs, to use a CGNAT template to point to a CGNAT on your BNG somewhere. How do you implement that? You can't do that on a bigger scale by doing it by ClickOps. So that's where now the automation comes in. So for my home labbing setup, I'm using several tools. I'm experimenting with several tools. Again, I'll show them. I'll show what I've done with them. There's a lot you can do. It's quite a lot. I've just tried to cover a bit, and then we can go to the demo. So I have GitLab. I'm just storing my scripts in there, my code. I also have Netbox. Netbox is a tool to document your network. I'll show you how mine looks like. And then there is an orchestration layer. So that's where your Ansible lives. That's where your Terraform lives. Then the tools to do the orchestration. You don't also want to be going to a server somewhere and doing Ansible, running your Ansible on the server yourself. That's prone to errors. And you can also, the process will not be well defined. If somebody comes in and changes something and runs it again, it changes your infrastructure. So the orchestration tools kind of prevent with that, because that's why you have the permission layers. you have the access, so you can have somebody that can only run the automation, they cannot edit it. So that's where the tools come in. So when it comes to like the cloud building VMs and all that kind of stuff, there's a tool called Packer by HashiCorp, Terraform, the same makers of Terraform, that can build your images. So this is gonna be a tool that builds your base for your VM. And then how do you like kind of now configure the VMs? Terraform does that. And then after you configure the VMs, how do you install your tools? How do you install application into it? How do you upgrade these VMs? Again, Ansible can also be used on routers and all that kind of stuff, because at the base of the router, you also have some of them are using Linux, some of them are using BSD-based systems. So Ansible can also do that, depending on what the vendor recommends. So these are the tools I'm using. I'm using Terraform, I'm using Ansible. I haven't used Packer very much. I have an orchestration tool called Kestra. I'll show that. And Semaphore can do Terraform, can do Ansible. I'll show that. I have GitLab for storing the code and all the repository. I have Netbox. So without boring you so much with the PPT, I'll just go show that, and you can see like with bash scripts, this is how you can write a bash script, but Terraform is more declarative in that format. And for those who are familiar with Terraform, you can store state. State is how your infrastructure looks like. So every time you want to make a change, the tool will check how is the infrastructure set up. Is there any conflict in this new change I'm making? And then it will declare all that for you, and you can see it, and before you go ahead and implement. But with scripts, you run it and it's stateless. So that's the benefit of moving away from kind of the imperative way of using scripts. Again, even in the networking world, you have scripts. Let's say you have a script to do a particular task on your network, and then that script can only be run once, and it doesn't have any states to it. You can see what the other person did with the script previously. But with this kind of setup, you can do that. So I'll go and show how I'm implementing all this, and I'll do a demo for the automation. Again, I'll also kind of provide this material later on, probably more documentation. If you want to understand how I'm doing it, again, it's not a tutorial. There is quite a lot of way to set it up. So I'll go to my handy dashboard, and so these are kind of my tools. I have two Netbox instances running. I have a test and a production one. Production in the sense that I want to essentially maintain that without corrupting it with my tests. So I'll go to the test one, and I'll show you. So this is my setup, and all the devices in my all the devices in my UniFi setup, they're all here, and you can see they're all here with the IP addresses, with the information, the roles, and I have a setup such a way that if I delete this record here, it's gonna sync up and bring all the information. If I go to UniFi and change the management IP for this node, it's gonna synchronize with this, and it's gonna, this will be now my kind of my documentation, because I know in IT we hate documentation, but I've set it up such a way that it does the documentation for me. If I can quickly show you the stack, there's quite a lot. But again, I can go to I have it in Sandbox VM because everything is test. This is the Netbox, and you can see you can see the Netbox application sits there, and this is the front end that we're accessing. The database, this is for housekeeping. This is Redis. Redis is a fast database, so that's how you're able to do stuff on the UI in a lightning pace, because you don't have to keep on fetching the data from the database every time. It can be on the Redis cache. Then this is the Waka. The Waka will be now the node that does all the stuff that you want to do, all the tasks you want to do in Netbox. And then this is just a community built tool that syncs stuff from UniFi. So UniFi has for those who use UniFi, they have they have a docs, they have documents. They have docs for how you can query the network. And let's say you want to query the network, and let's say list networks. You can see if you go to the website, they will show you, okay, this is how the output look like. If you want to use, let's say, Ansible, this is how your module look like in Ansible. If you want to use Python, this is how your module look like in Python. Again, you can go and now build all that. Again, I've tried to do that, and I'll show you that later on. You can do or put all that together and customize that to your specification, how you want to document your network. And then you can go run that automation, get all that information, send it to Networks, and that will be your documentation. Yeah, and again, IPAM. Again, this is technically not doing the IP management, but it's also showing you what the IP. So all the IPs I'm using on my nodes, they're all coming here. The VLANs, again, I'll show you. You can see all the VLANs in my Unify. They're all here and they're synchronized. And if I go to this kind of prefix, you can see there are already 11 IPs. These are all my management. You can see the management. Again, I don't know how my PlayStation got into the management network. I'll have to investigate that. Again, you can see I have this documented, and you can synchronize every time. There is also an automation to synchronize it. So I'll go to the automation tools now to do the demo. So let's start with a simple task. Let's start with a simple task. Let's say I want to create a virtual machine, because that's the task that's very boring and repetitive. Like every time I want to create a new application or do a new lab, I need to create a virtual machine for that lab. So why not automate that? So I'll go to that and kind of just show a diagram of how this all looks like. So this will be set up in Semaphore. Everything will be stored in GitLab, and then GitLab repo, and then Semaphore will clone. So this is just a tool that reads how I want to define my infrastructure. It will clone that, and then it will read the state. Again, the state is the memory. Read the memory from GitLab, and then it'll do the apply, and then it'll go use the token, API token, to connect to my Proxmox node. It'll bundle up the VM, create the VM, and then boot it. So I want to just demonstrate now. This is just a pipeline. I want to now demonstrate using Semaphore, using Terraform. So I'll go to my Semaphore instance again. So I've run this before, but again, it doesn't help. It doesn't hurt to do it prior. But I've run this, but so this is now the Terraform. The Terraform task to create the VM. I can go to my GitLab. Sorry, I'm moving through tabs so fast. I'll go to GitLab and show you. Again, this is my self-hosted GitLab, so everything is not online. I'm just doing it in-house. I'll go to home, and I'll go make sure I'm in the right user, and then go there and make sure I'm in the right project. So this is the Terraform VM create project, and you can see my definition, Terraform main.tf. So this is how I want to bootstrap a VM. I want it to use DHCP, all that kind of stuff. The VLAN I want the VM to be on. It's all defined here. It's all defined here. Again, Terraform is a tool you can use. I have the node I want to target, all that. Enough with all this. Let me just show you the 8 in action. So I'll pull the target node on the sides to show you the 8 in action. I'll log into the node I'm targeting the automation to. So this is the node. I want the task to go here, clone this VM right here, and create it, and then it will create a VM 500. That's what I have in there. And let me just put it side by side so that we can see it as it's in action. Right, where are you? There we go. So I'll put this side by side, and I can just gonna mess up my stuff. That and that. Okay, so I have it side by side. I'll come to my automation, back to the task, and I'll run it. Again, there's a plan. The plan will just go and check what you intend to do. So I'll run the plan. So it'll just succeeded, and it outputs everything you want to do. You want to do the VM. You can see the DNS configs. You want the VM to come up with a DHCP IP, the SSH public key, and all the setup, all the networking setup, the VLANs, and all that kind of stuff, all that kind of good stuff. So the plan is successful. I'll go just now create. I'll go to auto approve, run that, and you can watch here. With once I auto approve it, the VM will come up. Awaiting confirmation. I'll just, again, you can see this is what it intends to do. It needs to create a VM called VM test. This is the node creating, and then that's the VM ID, and I'll do that. And again, you can watch the VM being created there. Again, this is possible. So if you want to create like 1,000 VMs, you can create a similar setup and do the same. If you want to update, I'm just showing you the beauty of networking. You see the VM is there and it's booted up, and if I can go and log into it, console, and Ubuntu, and you can see the okay, there you go. You can see the VM is there, and it has that definition. It has the DHCP IP, and if I go to the VM and go to summary, you can see it's bootstrapped with VLAN 50. VLAN 50 is my network, so it got an IP address from that pool of IPs from VLAN 50. Let's say now I want to go and target this VM. I want to install an application to it. So you can do that now with Ansible. Again, I have not that this is just for test. So again, I have another repo for another project just to bootstrap the VM. So it'll come in. Let me see. Again, I can show you in just a diagram format instead of doing the code. But again, this is just a provision. This is VM Terraform provisioning. That's what we just did. And then I want to do. I want to bootstrap. Where is the bootstrap? Oh. There we go. So I want to bootstrap the VM. So put this in full screen. It's quite a lot of tasks, and every time I want to do something, I have to do all this. I have to do all these kind of stuff. I have to go into the VM. Once the VM boots up, I need to go install the tools like the ping tools, Carl, Vim, HTOP, JQ, Tmax, all that, and also now go install Docker and Docker CE, Docker Compose, Community Edition, and then do all that and set up all that manually. But I can do that with automation easily. So I'll just go to this and I'll just go to my inventory for a bit. Bootstrap, I'll edit my inventory. I want to target the IP I just created. So that's the inventory I want to target. Then save, and then I'll go bootstrap that VM. Again, this is all set up so that you can install all the tools and run an application just as a demo. And I'll go skip the dry run and just run it. Hoping I'm not cutting it close with time. Again, it'll take like a few minutes, a few seconds. It's gonna go find my VM and do all that. Again, not sure how long it'll take, but okay, it's working. Installing Docker, you can see all the tasks I defined in the Ansible files in my Git repo. And then you can see it's now pulling the container, and then this is the application it just installed, and it exposed it on that port. And if I go to this here now, I'll be able to reach the application it just installed as a test. And voila, it has the IT tools application right there. IT tools can do a lot. Like even for networking, if you struggle with subnetting, it has a subnet calculator somewhere around here, if I can find it. It has IPv4 subnet calculator, IPv4 range expander, all that kind of stuff. Okay, my other automation avenue is I can kill all these. Okay. So again, sorry. So if I want to clean up again, let's say I want to remove that VM, I can go to this, the create. I'll click on it, and I'll go do destroy. Let me just do destroy, and I'll run destroy, and then maybe you can log into it and then show you the VM getting destroyed. And you can see it's accessing all that. I need to go up and approve the destroy. It just told me this is what I want to do. I want to go to this machine. I want to find VM 500 with this IP address, and I want to remove it from this host. That's all defined in Terraform, so I can just go and approve. And confirmed. If I come back here and you see the VM getting shut down, you can see the VM is shut down and it's gone. It's cleaned up. The other plan automation avenue I've been exploring is workflows. So workflows. So let's say the same kind of setup. So like the same kind of, so do the same setup and then do documentation at the same time. Document this at the same time. So I go to use the same tool, the same Terraform tool, create, apply the tool, apply the Terraform, apply the Terraform and manifest, and then create the VM, and then record all that output, and then send that to Netbox. Send all that to Netbox, and it will register that. If it fails, it will just notify me in Slack or any other tool I'm using to notify. So let me test -VM, and I can give it a VM of, let's go back here. Nothing is created with 999, so I'll just go and use 999, and I'll leave that default. Tenant, admin, platform, it will tell me Ubuntu, role will be Kubernetes first. So these are just tags I want to put in. I want to put in Netbox when I'm documenting this VM. Disk size. The default is 20, so you can go below the default, so I'll just do 20. And so again, this workflow now will create the VM and then document for me in Netbox, and I can run it, and I can go now check the output. Now it's doing the same thing I was doing in Semaphore. It's referencing the same Git repo. I defined my VM, but with other custom variables I just put in there. And you can see the workflow is running with the and then the other tasks pass, waits for DHCP. It gets a DHCP IP. You can see it got an IP, register Netbox, success. So you go to Netbox and go to my virtualization and go to virtual machines, and you can see what you create. Where you got test VM. Let's see what we created a VM with 50.98. If we go back to Netbox, you should see 50.98, 198. There you go. That's the test VM we just created, and you can see it has my tags. And again, this will help you even with all the IPs, and you can see I can go see all the IPs in that network. In that VLAN 50, you can see all the hosts in the network that are in that VLAN. It's all documented here. For networking, I've also been using, I'm not going to do a demo for that, but I've been using flows to, again, these are all tests. This is how I'm getting all the data into Netbox from UniFi. There is a flow I'm using for like sync. I can just show you the topology. Oh, that's not it. Version 1, maybe version 1 topology. And you can see there's quite a lot. It does daily, so it's a cron job. And then gets the site ID, fetches the data, transforms the data. Again, I'm baking in the Python's the Python instructions that are provided by UniFi to hit the API endpoint, clean up all that data, and then send that to Netbox. That's how I'm able to kind of get all that data without having to come here and document it manually. Like if I go to my IP addresses, like I have quite a lot of IP addresses in here. I can do all this, like all my IoT devices are in here. I need to document which IoT device has what IP address, and I need to have somewhere I can go reference that. So this does it just constantly hits that API endpoint on a there is the cron job set up here daily, runs on a day-to-day basis, and it updates all that. That's mostly what I've been doing in terms of automation. Again, there is a bigger avenue to do this. You can try now this. If you're more inclined to networking, you can try building your similar workflow. Let's say you want to get data from your routers, all that kind of stuff, your virtual routers. You can build a similar automation workflow using similar kind of tools. This was just to show you that there are tools out there, and there is a method to do it. Observability. So you don't want to be blind how your network looks like. So you need to see your metrics, your DNS, your infrastructure, and all that kind of stuff. So I'm using several stacks to observe my network, using Grafana to build dashboards. So you can either store your data in InfluxDB. It depends on how you collect it, but you can collect the metrics, pull them to InfluxDB, and then visualize them in Grafana. You can also do the same with Prometheus. This is another tool you can learn about. Again, this is stuff that's outside the networking, but it is what makes the network work up there. If you're running a big telco, you need to be able to see all that. If you have your wireless technology, the 5G and all that kind of stuff, your application, all that, you need to be able to collect all this data, make sense out of it, so that if something is broken on the network layer, you can be able to tell directly from your dashboards. So I'll go and show you my dashboards so I have Grafana somewhere, if I can find it. Where are you, Grafana? Okay, just go to services and Grafana right here. So this is my Grafana instance. I'll just show you a couple of dashboards I have. So I have some favorite dashboards. So I'm collecting DNS metrics. So I want to see my DNS metrics in the big dashboard, and that's how like a DNS dashboard looks like. You can see all this data is in that application, but I don't have to log into that application. I can just have this on a screen somewhere. I can see all that information in there, all that data. I also have another dashboard for, again, I'll just show you whichever I have a bit refined. My nodes, my Proxmox nodes, let's say the node that's doing all the heavy lifting, You can see all my VMs in there, the CPU usage, memory usage, and I can also come in here and drill down per VM. You can see I can drill down per VM and get all that information. So this is something good to have even in a network. Again, for let's say power consumption and all that kind of stuff, I have another dashboard that's polling my PDU, the UniFi PDU, and you can see all these are the ports on the PDU. So like let's find a port that has a label on it. So this is the switch. You can see the switch, and you can see like my power consumption from the switch connected to the PDU. It's getting all that all those metrics, pushing them to InfluxDB. I can show you how InfluxDB looks like. So this is my InfluxDB setup. Again, the data is stored in buckets. So you can see I have a Home Assistant bucket collecting all the Home Assistant IoT, and okay, so yes, I'll go to the next section so that we can go Q&A. Again, why does this all matter? You can tie it all together. It's quite a lot to learn when you set up your home lab, your networking stuff, the career path, the certification path, the career path. You can do the sysadmin. Again, you don't have to be in one career path if networking is not your main passion, but you have understood networking, you want to venture into something else. Home lab will be something good to do it, and all that. I have created a roadmap, kind of just show you. I'll share that with you, but I'll just open it and then I'll share that later on, so that we can go to Q&A. I know you have quite a lot of questions. I'll try to make this. I've created a roadmap for like the home labbing stuff, kind of just glue everything together, and it starts with selecting your hardware, the options you might have, compute the options you might have, depending on your budget, selecting your hypervisor, your automation part, the containers, CI/CD, what you need to run, and then doing stuff with netbooks, all that kind of stuff, and then hosting everything and some resources that will be helpful to you. This has been long, so I'll just open up the Q&As.
Thank you, Peter, for that informative session. There is a lot to cover in that short session, but I believe guys have questions. They have been sharing some questions on the chat. If you can just go to the chat and start by those questions.
Okay, so I'll go to the chat and I'll look at the questions. If I can find where the chat is.
What system do you use for DNS, and how do you protect the same DNS service?
So I'm using Technetium. It's an open source DNS server. It comes pre-baked with the, it has API access, so I can poll it with my, get the metrics. I can also write DNS records into it through an automation. So if I have an automation baked in, I can do that. There is Pi-hole in Home Lab. I don't think you'd use that in a business. Technetium can be used in a business. AdGuard Home, there is that. You can also use OpenSense or pfSense. You can do your records in there. Most people tend to separate so that you don't want to put all your eggs in one basket. So that's kind of it.
Okay, the next question still from Shebo. What will be the best practice running DHCP from data center or locally?
The best practice?
Running DHCP from data center or locally. So he's asking whether DHCP should be run from data center or running it locally.
So for my setup, I'm doing it locally. centralizing all that to the network controller. It can also check for conflicts and all that kind of stuff. It depends on your setup. It depends on your setup. Also, for data center setup, they have for data center setup. Let me just show my screen here. This is just to answer the question. So for data center setup, if I go to they have IPAM. You can bake in your IPAM into the setup. IPAM. You can bake in your Lord. I don't have any IPAM configured, but you can bake in, so you can have your source of truth like Netbox, Inflobox. You can have it doing your DNS. Not your DNS, DHCP. Sorry, DHCP. Yeah, you can have it doing your DHCP. So there is quite a lot of ways to do it. It depends on your infrastructure and the setup you want to set. But for my case, I do it directly from the network controller. It also checks for conflict and all that kind of stuff. It checks for rogue DHCP server in the network, and which is a nice thing to have.
Okay, for the Zabbix monitoring, he's asking whether you can integrate it with SMS gateway so that you can get relevant notifications whenever there is a system or network device going down. I believe there is possible. Maybe you can comment on it, but I believe it should be possible.
Yeah, there is integration. Most of it is documented in the Zabbix talks. Most of it, they want you to pay for enterprise support to be able to kind of set it up. But if I can share my screen really quickly, I can show you. I don't have it set up, but there is a way to set it up. Share. So Zabbix alerting, you can have triggers, and now you can have it sending it to your. You can have it sending it. You can configure it to send it to whichever alerting tool you're using. If you're using PagerDuty, if you're using Slack, if you're using Microsoft Teams, again, some of those integration might require you to have enterprise support, or just not the community edition tier they offer.
Okay. Any other question from the audience? Any other question? You can raise up your hand and ask your question.
I know it's quite a lot to try and compress all it in one session, but I hope you got something. I hope like you have now a picture, because you see, mostly when I was sitting just on the networking part, I didn't quite understand like how the application layer is being affected by the network down there. But you can see if I go make a mistake in the VLAN configuration, or just go make a mistake in my Open Fabric setup, an application is on the Fabric, it's not going to be reachable. It's going to have a problem. But with this kind of home lab, you can be able to kind of see all that, like how a million ways how an application can break, and somehow it's not always network issues. It can also always be DNS. So yeah.
So I'll share the GitHub link on the chat.
Yeah, I'll share my GitHub link. Most of my stuff is self-hosted internally, like in GitLab, but I'll try to push as many as possible. But I have some of the labs in there that I've done on EVNG, like 1 or 2. So I'll share my GitHub. I'll share my GitHub.
Okay. Any other
question?
Share my
GitHub.
Any other question or comment from the audience before we call it off?
So the project I specifically referenced for 5G, I'll actually reference that. Again, I know this is not typical. Let me see. Quite a lot of the group was asking about like setting network emulators. This is how I do the network emulation. Like I use Pinet quite a lot. This is a new installation, fresh installation, if you can see my screen. And again, you can go to the community library, you can get some setups from like people. This is a CCIE BGP lab setup by this guy here. You can go get that, set it up, learn from it, set it up for yourself from scratch. This lives on my lives on my server here. Again, you can see I have it installed there. The beauty of this is, if let's say I want to set up, if I want to set up in the topology, inside the topology, let's say I want to set up Zabbix to monitor the virtual routers, and I want Zabbix to live outside Pinet Lab, I can come in and create a VM, install Zabbix in that VM, and make sure that this here also is in the same network, so that I can pass that network to Zabbix, and all my metrics can leave the Pinet Lab VM, come to the Zabbix, and they are documented, all that. That's kind of the beauty of having a hypervisor installed. And this can, if you have a PC that's a bit more capable, and you have another working laptop, let's say a lower spec laptop, but you carry everywhere, and then the other PC just is at home, you can install a hypervisor like this, and then have all your tools in there, and you can do all the home labbing. Like the 5G, I was also doing it on here, so you can see I have the control plane, the UPF, separate VMs with Kubernetes, and they are all in the network, and then I connect them to different networks. So the 5G networks, I've defined the interfaces, the 5G interface, the N1, N2, all those. I've modeled those as like physical networks. Again, you can go even deeper and connect those to virtual routers and use VRFs and all that kind of sweet stuff we love as network engineers.
Any question from the audience? Any question? Any comment? I hope we've all learned something from the presentation, one or two things. And I believe going forward, we will be having more presentations so that we can all understand how we can do the labs. I know the expectation was that we are taking you through maybe EVNG or GNS3 for your home labbing, but that one can also be organized so that you get to understand how you can set up your home lab using those virtual tools like EVNG or GNS3. Brian, what is your recommendation? Brian is asking whether you can incorporate sharing your setup for collaboration via tunnels for team projects at a fee.
That's something I can explore. I mean, I know the home labbing community does that, and yeah, I can spin up a few VMs. Somebody wants to test them, and yeah, there are also tools like Tailscale. Tailscale is a peer-to-peer VPN. I can create Tailscale and add people to it. There is a way to set it up. I'll look into that. Yeah.
Then I hope that would be it for yes.
Okay, so just curious, the hardware specs you started with and what you have now, maybe some mini PCs you can recommend for someone who might want to start exploring. Actually, this has been, I wasn't expecting this, but it has been a really nice session that has exposed us to a lot of things.
Yeah, my objective was, like, when I sent Martin what I want to go through, I didn't want to sit here and show you, okay, this is how you set up, this is how you set up EVNG, this is how you set up. We can have a session for that. My objective was to kind of, if there are new people, even existing people, kind of open your eyes to what the industry is doing. Also share my perspective of how I'm doing it, and kind of show you that there is a lot more than just the networking in the traditional aspect. Back to your question, my setup. If I can go to, I don't want to bore you with my slides again, but if I can go back to the slides, that's what I have on my setup. My setup. I started with this PC right there, that gaming PC up there, and that could comfortably run PNetLab and then some containers in a VM. It also had it was a old gaming laptop. It had a small GPU, so I'd also be able to install and run local AI models using Ollama and all kind of stuff. So you don't need much to get started. If you have a gaming PC that's retired, or you can get your hands on a gaming PC that's used, you can start from there. And then these are pretty like cheap switches. Like this one was like $30. I know but it was discounted. If you get it used, you can get it for like $15 used, and it's a managed switch. You can do layer 2. You can segment your network with VLANs and all that kind of stuff. Again, there's also the avenue using Raspberry Pi. It's Raspberry Pi economic-wise, it's not economical. You just rather just go get a mini PC like this one or this one. Yeah.
Okay. The old gaming PC was the name. It was maybe like the name, more details.
The old gaming PC was, if I can remember, it's been quite a while since this was what's my wife's
Or
name?
the mini PCs, maybe more details on it, like the name.
So the mini PC was this mini PC was a GMK Tech. There is one that's Cyber Geeks. I just got the generic mini PCs that China has to offer, and they're very cheap.
Okay.
Yeah.
Nice. Okay.
You don't have to start with a similar PC. You can
You can start with anything that has quite a bit of memory and like even 4 CPU cores would be a good start.
Okay. But actually, it will. Okay. Yeah, it doesn't have to be similar, yes, but at least we see it's possible. Okay.
Yeah, it's possible. This is like low budget. Here, the budget was very minimal because most of this I got used. I just tried to find used, and I bought it used. Some of the stuff that's new is just the unified stuff because I wanted a solid foundation for the network. Like I didn't want to have Wi-Fi dropping randomly at home when working from home, all that kind of stuff. So I decided to invest that and kind of separate that from the other experimentation stuff.
That's great. That's nice. Yeah. So thank you for sharing all this.
Okay. Thanks again, Peter, for your time. I know it has taken some time and effort to prepare, and also waking up that early to do the presentation to the community.
It's actually my bad. I woke up too early. I didn't factor in the daylight saving time.
Yes, we appreciate that, and we are looking forward to having you again. Maybe share more knowledge on this. I know today it was a crash course, a lot to cover within the 2-hour session, but I hope in the future we can have more sessions going deeper into the setup and just trying to make us understand how we can implement these different aspects of networking. So we really appreciate your time and effort, and also appreciate the engineers who've managed to join and to actively participate throughout the session.
Yeah. Again, yeah. again, like I said, being an engineer, you have to be uncomfortable learning new things. I mean, you have to be comfortable being uncomfortable learning new things because, again, the network, you can see with all the AI stuff, the network is also kind of changing now. Like the way the network was being built before is kind of also evolving to accommodate that. You also have to keep up. You also have to keep up and kind of also, just being comfortable, learn the new stuff, and also kind of, if you want to use it for your career, use it for your business, all that kind of stuff.
That's very true. Okay, then we can call it off, and guys can enjoy the rest of their weekend. The recording will be available. It will be uploaded and shared with the team. Peter, you can also share the requested resources in the WhatsApp group so that guys can be able to access it from there.
Yeah, I can share my GitHub repo. Again, I don't have a lot because I have my repos self-hosted internally. I can push some of them to the public repo if you want to see how I've set it up. Yeah, it's always good to kind of share. Yeah.
Thank you so much again for your time. We appreciate the effort, and we can call it off and have a good weekend, guys.
Have a good weekend, everyone. Thank you.
Martin.
Yes, David.
Thank you.
Can I steal 5 minutes of your time, sir? Or you want to watch yeah, on the call. On the call.
Maybe I can give you a call.
Yeah, it's fine. Yeah, fine.